Okay, hello everybody. This is going to be the first part of at least two videos for today, and it's going to talk just about our sorted dictionary scenario that I posted. So hopefully you all saw the Canvas post that survey that I asked. What would you do in this sort of scenario? So I want you to imagine you just completed the single list and hash dictionaries, and your boss comes in and asks, we need, or tells you we need one that's sorted, like how long it would take, and you're like, well, I need to maybe build a binary search tree, and like it would take, a certain amount of time for that. And he's like, yeah, you got 15 minutes. Now, I went on to shoot this video with my son about it, and when I described it to him as a scenario, I said an hour, and he thought it wasn't funny enough, so and suggested the 60-minute line. So we've gone with the 60 minutes version of this whole thing. Some of the responses that you guys had, a lot of really great responses. One of them was just build it. Build the binary search tree, or like search for one. There should be, that was someone else also brought this up, where you, like, who says I have to build my own binary search tree? Let me just go find one. Just bust it out, get it done in 45 minutes, and then start working on your next project in 15. I like the confidence, pretty good there. Another one I wanted to at least link to everybody. I'm not going to go over the whole thing. It was pretty great. It's like, well, if I didn't have time to build these, and then describes this fantastic algorithm with big O of square root of n time, where I'll let everybody sort of look into it, and I love the end. But I think they'd probably take longer to code this thing as it would be the binary search tree. Either way, I liked it, and I'm going to leave it in for you guys to check it out if you're interested. Like this answer: enjoy life as much as possible you can for an hour, and then when the pipe, when it's time to pay the piper, you just deal with it. This person is going to travel somewhere else in the universe where time is slower, and then come back. I mean, why come back, honestly, if you're just going to be in trouble after an hour where you haven't built this thing? I like this one too. Just submit the unsorted version, and just to obfuscate the code as much as possible so people can't tell that it's unsorted, and then claim performance. So I kind of like that. It's due to some craziness, and just obfuscate and just be combative as a strategy, and just don't produce a sorted version. This is a good one. I'm surprised more people didn't say this. Just consider quitting my job and going back to grad school, which I like, or like polish up your resume for an hour and get ready to go work with someplace that's a little more reasonable. There were a ton of people, or a fair number of people, who said, like, let's just modify single list dictionary and sort it all the time. It's just like a lot of different takes on this, where it's like, well, every time you put it in, I'm like either gonna build a whole new one with it sorted, or I'm gonna insert it in place. And that was certainly a common theme throughout. And I like this one bonus add-on from somebody, that let's just interview the client and figure out whether they actually need a sorted dictionary. I mean, who's going to trust that chucklehead manager in that video? But the other thing is, like, how are they going to evaluate whether or not I actually did it? And I think that's an important question. So along those lines, this is sort of getting to the equivalent situation, is when is the fact that it's sorted relevant? Okay, and I'd like everyone to pause the video and think about that and come up with their answer. Okay, and we're back. And what I would say is, a lot of people were talking about like sorting whenever you did put or remove, which is totally fine. Some people pointed out that if put is sorted, then remove doesn't need to do anything, which I think is valid and very true. But that one can just either fix put and then everything's okay, or you can just use a single list dictionary the whole time and just sort before entries returns. Keys and values will undoubtedly call entries, so there's just one moment here in which it matters. Now, if you use single list dictionary, the performance won't be as good, but from an equivalence standpoint, you could, if you were given 15 minutes or an hour, just whip up something that used your working single list dictionary, and then sorted either put when you were doing it, or you could be like, I'm just going to use single list dictionary straight up, and then just sort the entries before they return, and that would work. And so what I'm going to do right now is build, hopefully, a 15-minute version of this situation. So I have sorted dictionary here. I've included single list dictionary, so I'm ready to go. And I'm going to make my dictionary be a tuple that is going to be the compare function, right? And that's going to be a product type with, it's going to be a tuple where it's going to be the compare, oh, sorry, I have to say key here, the compare function. And then I'm going to just use, I'm going to parenthesize the heck out of this, a key value single list dictionary dot dictionary, and that's going to be my type, dictionary. Okay, and when I come in here and I got to create this guy, I'm simply going to return the tuple that is the compare function and single list dictionary dot create. And all of these guys, right, where I have this dictionary, I can take this out. I'm going to make this a little bit simpler and just say that I'm going to pass in this thing and I'm going to say, yeah, I don't care about the compare function right now. And I'm going to call this adaptee. So that's going to be my single list dictionary. And I'm just going to say, well, get for this guy is literally single list dictionary dot get on the adaptee. Like that's all that function is. Now I have to pass the key, right? That's that guy, and this guy is going to be, again, I'm going to replace dictionary with that because it can be a pattern. I could do it as dict and leave it there, obviously, but I could do it right here. I could leave dict and do my let expression and pull it out, but I'm just going to, in the interest of time, just do this where I put the pattern right in the parameter. So now I'm going to put key and value. I'm going to remove the key itself from this guy. And let's just say that I also do just entries. Great. I'd like everyone to pause the video and figure out whether or not they're, how they feel about this approach, whether or not it's going to work, what's wrong with it. I'll just give you a quick heads up, there's something wrong with this. And when you're done, unpause. Okay, and we're back. So like, hopefully a lot of you sort of note that like, it can't just be the single list dictionary because it's the single list dictionary won't be sorted. So if I run this, and indeed, well, actually, apparently I have an error. So let's debug that real quick. Oh boy, of course it's in the declaration of this thing. So that guy goes there, and I need one more paren. There you go. Oh, nope, nope. All right, so that is that one, and that guy is that guy. So this is a key compare function, ORed with this thing. Oh, sorry. No, that's right. And single list dictionary. So the key dictionary, and that guy, and that's a compare function. I don't see why that's not good. Let's see what it's telling me. Line 25. Oh, it's actually moved on. So I actually fixed that bug. So that's good. Oh, I forgot to put in here. All right. And that returns that. No, there's the adaptee. So that's, oh, right. So there's only one parameter entries. Okay, so here we go. We're back. So this thing is working. Always good to read the output and not just guess that it's still up here. So hopefully most of you realize that like you can't just like use single list dictionary completely. I've got to do this. Now a lot of you said I'm going to fix put. I'm going to just sort this guy. So I need to define a function to use list sort. It's just a slight adaptation of it. So I'm going to do this thing where I'm going to say the sorts compare, which is slightly different than the compare function I have. That's going to take 2 entries now, and I'm going to call them AK, and I could call them AV, but I don't really care about the value, so I'm just going to use underscore, and BK and underscore. Okay, and so that's going to be my sort function, and it's going to use the compare function. Now I need this, of course, so I'm going to call compare of AK and BK and see if that is, if that's greater, I think is the right way to do this. Okay. And now I've got the entries back. I can actually just grab them and I'm going to call it val unsorted entries. Just to be clear about this, I can call my adaptee, right, because I'm adapting the single list into the sorted one. And now I'm all good. Now there's this thing called list merge sort, which I could look up on the web and most of the stuff that has sort. It is, of course, curried. So I'm going to pass sort, compare, and the unsorted entries. And this should start to make everything work. Okay, so now we're good. And just to go back to our scenario here, hopefully that took less than 15 minutes, even with the bug. Once it's deployed, like, so you deploy this in 15 minutes or an hour, and you're like, okay, and so the performance is now log n, and now I got this n log n, like entries, I get this n log n sorting that's on entries, but it's out there, it's working, and I can get to work, get about building my binary search tree, which have that nice log performance and everything like that, and replace it later, and no one's code will break and everything's good. It's one of the nice things about having signatures like this. A lot of people, so as many people who built it as a single list dictionary, did some combination of things. This person had a single list and a hash table to keep the key value pairs. A lot of people was like, use a hash function that maintains the order, and sort of is getting into the fact that this could be difficult, right? There's a number of people like went down this road. One of the nice ones was like, you know, trying to figure out like, well, I'll assume it's a string, right? And just do that and try to build a hash function based on the first letter and everything. It's like, well, first of all, good luck getting SML to convert it from an alpha, any alpha type to a string. So it's not going to work. It's not going to compile that way. But the other one is you'd like to be able to support any type that has any compare function, right? Like even with strings, you might want to be able to like say sorted and have it be reversed, right? So any arbitrary compare function, they're literally passing you the compare function they want, but they very critically are not passing you the hash function. So I want you to assume the following scenario, a little further scenario. We built single list dictionary because this is a course in university. But largely, no one builds the single list dictionary. It's very reasonable to assume that you have a hash dictionary lying around. But it requires a hash function. And if I want to do this equivalence thing, it would be ridiculous for me to have a sorted dictionary where people had to pass a hash function, right? People are only going to pass you the compare function, right? So if I wanted to use hash dictionary, how would I go about building it in the same way, except I want you to imagine we don't have single list dictionary. So to be very clear, you're past the compare function, you have no hash function. How do you still use hash dictionary? I'd like everyone to pause, think about it for a little bit, and then come back. Okay, so we're back. And so hopefully, at least some of you, or hopefully all of you, sort of realize that you can always write a pessimal but correct hash function and use it in that way. So let's do the second demo here. We're going to build sorted dictionary, the hashed edition. Okay, so let's go back here, and I want you to imagine instead of using single list dictionary, let's use the hash dictionary that we created. And do sort of the same thing, right? Except that so I need to hang on to the compare function again, right? Because I'm going to need it to sort the values when I'm done, right? The entries. But I'm going to have a hash dictionary this time. Dictionary. Okay. Now, it's really easy for me to replace all these guys, right? Everything else should be the same, right? Except I can't just create here. I need a function, right? And so let me make what I'm going to call like pessimal but correct hash. Okay, and so given any object k, right, any key, I'm just going to say that's 0. You can pick any number you want, right? And you're just like every single object will go to the same list, right? And then all I need to do is return some tuple that uses some number of keys. Now I might as well just make it 1, right? But you could use any number, right? Like they're all going to go to one spot, right? But now I can do that and my decimal but correct hash. Okay, and now that's how you build that one. Okay, and so it's the same thing, except I'm just going to be like, all right, let me just use this. Let me just use a hash function that just says put everybody in the same list. So the performance is just as bad, if not worse, because I have to, slightly worse, because I have to call this all the time. But everyone just goes into the single list. And to be very clear, I can pick any number I want here, like 425, right? It will also work, right? Because it'll mod it with 1, and what do you know? It'll show up in 0. And again, I can use any number of these, right? Doesn't matter. They'll all show up in the same spot and work, okay? But I would say do this. I would call it decimal but correct hash function, and go. So just sort of go back here. What I like this is a person who was sort of went down this kind of, I'm going to use a hash table and trying to put everybody sort of in the right spot. They've got kind of this idea that you could call the compare and see if it was bigger or not, I think. Sort of started to realize that this hash thing is going to be sort of difficult, and then says, you know what I'm going to do is I'm going to ask more questions. This is not a bad life lesson in general. If you ever start getting unreasonable demands from like your boss, one of the best pieces of advice I heard was to ask questions and ask them, all right, well, I've got all these things that you want me to do. What's your what's the top priority, right? Getting that back in that way can sort of put the thing back on them. It's a very respectful way to do that, because managers should be thinking about priorities and stuff like that. And so, yeah, go back and ask more questions is always a good idea. And with that, we're going to say goodbye to ML. It's one of the sad things about this class, I think, is that as soon as you start to get good at ML, right when you're sort of finishing up with sorted list dictionary, I feel like we're all sort of starting to get the hang of it, right? We're starting to be able to debug things. We're starting to be able to get into the ML mode. And then it's like, all right, now we're done. Let's move on to Racket. But either way, that's what we're going to do.